Previous slide, we learned that this test to prove the convergence or divergence of this would be our limit comparison test. And our rationale for that is that when we look at this series, we have this denominator that has an element of a p series, but not quite. Okay, it's close to a p series, but we've got this subtraction that kind of messes with it a little bit. However, it might behave like a p-series. So what we're going to do is we're going to choose a p-series to compare it to. So I'm going to say compare to the p-series of 8 over n to the 4th. Now I chose to put an 8 there. I could have also compared it to just 1 over n to the 4th. Any number really on top, because the n to the 4th is what is defining it. If we compare it to this, what we know about this p-series is that this converges because p is equal to 4 and that is greater than 1. So we can make that statement that p-series converges. Now using the limit comparison test, we're going to take the limit as n approaches infinity of our original, which is 8 over n to the 4th minus n cubed, and we're going to divide by our comparison. But when we divide, we're really just multiplying by the reciprocal. By doing this limit, we see we still have an n to the 4th and an n to the 4th. Now technically we also have these 8's in, but those 8's are just going to cancel. This limit is equal to 1, which is not equal to 0 or infinity. Now that is the result we really want to have, because if that is true, that we get a number that's not 0 or infinity, then whatever our comparison does, our original one does as well. So I can now write a conclusion statement. And the conclusion statement would be that the series of 8 over n to the 4th minus n cubed converges by the limit comparison test. And remember, on your test, writing out the exact series is going to be really important because there's two series in here, so you must be explicit on your test.